Namaste. Welcome to Pythagoras Academy. In this video, we'll see how to apply pseudo force. Let us take this example. There is a wedge, movable wedge lying on a smooth horizontal floor, and the block of mass m is placed on it. And the question is, with what acceleration should the wedge move so that the block does not slide with respect to the wedge? And there is no friction between the wedge and the block. All the surfaces are ideal, which are smooth. So we don't have to bother about friction. There are two different ways to approach this problem. Number one, we can work from ground frame of reference. So when you work from ground frame of reference, because it is inertial frame of reference, you don't have to bother about pseudo force. Let us see that first from ground frame. I am drawing the free body diagram of the block. So this is a block of mass m, and I observe that there are two forces acting on the block, its own weight mg acting downwards, and normal force applied by the wedge perpendicular to the wedge surface. So this is the normal force. If the block does not slide with respect to the wedge, if you observe this block from the ground, block is moving along with the wedge with common acceleration a, because with respect to wedge the block is not sliding. So that is the reason we can conclude that if the wedge has acceleration a, block will also have acceleration a in case the block is not sliding with respect to wedge. So acceleration of the block as observed from the ground is a in the horizontal direction. So angle of inclination of the wedge is theta. So this would be theta and this is theta. Now resolving the forces. We have already discussed in one of the videos of free body diagram that when you resolve the forces, it is always that force which is inclined with the line of acceleration that should be resolved. Mg is already perpendicular to acceleration, so you don't have to resolve mg. Normal force is at some angle with the acceleration, so resolve normal force. So resolve the forces along and perpendicular to line of acceleration. So this would be n cos theta in the horizontal and in the vertical direction, and n sin theta in the horizontal direction. Now in the horizontal direction, net force acting on the block is n sin theta, which is giving it acceleration a. Net force is mass into acceleration by Newton's second law. This is the first equation. And in the vertical direction, the system is in equilibrium, or n cos theta is balancing mg. So n cos theta is equal to mg, or n cos theta minus mg is 0. Anyway, you can interpret this. Now equation 1 divided by equation 2, sin theta by cos theta, that would be tan theta. You got rid of n, and in the RHS it is a by g. So a is equal to g tan theta. If the wedge moves with an acceleration equal to g tan theta, the block does not slide with respect to the wedge. So this is how we work out from ground frame of reference. Now same problem will work out from wedge frame of reference. Observe the difference. Because wedge has got some acceleration in the horizontal direction, it is a non-inertial frame of reference. And for any non-inertial frame of reference, when you are working from a non-inertial frame of reference, you should not forget to consider pseudo force apart from all the forces. So let us draw the free body diagram of the block, and it has got two actual forces, mg, and perpendicular to the surface of the wedge there is normal force. And apart from these two actual forces, there is pseudo force because we are working from non-inertial frame, and direction of pseudo force is opposite to the acceleration of frame of reference, and magnitude is mass of the system into acceleration of frame of reference. So there is force ma acting on it. Only if you apply pseudo force, you can apply Newton's laws from a non-inertial frame of reference. Now resolving the forces, so theta, this would be theta, this is theta. The block is at rest with respect to the wedge. Because you are working from wedge frame of reference, if you stand on the wedge and observe the block, it is not sliding with respect to the block, so the block will be at rest with respect to the wedge. So acceleration of the block with respect to the wedge is 0. Now resolve. n cos theta in the vertical direction and n sin theta in the horizontal direction. Now net force acting on the system is 0 both along horizontal and along vertical. So along horizontal net force is 0, n sin theta minus ma is 0, or n sin theta is equal to ma. So this is the first equation. And n cos theta minus mg is 0, or n cos theta is equal to mg. N cos theta is balancing mg and n sin theta is balancing the pseudo force ma. So this is equation 2. Same thing, 1 divided by 2 tan theta is equal to a by g. A is equal to g tan theta. This is how you work from wedge frame of reference. Now whether it is from ground frame or wedge frame, the equation 1 and 2 are exactly same, but the interpretation of these equations is completely different if you observe equation 1 and 1 in two different cases. In the first case, n sin theta is the net force which is giving acceleration a, so n sin theta is equal to mg. From the wedge frame of reference, n sin theta minus ma, the force ma, it is not, there is no acceleration, but the force is ma, n sin theta minus ma is 0, that gave rise to n sin theta is equal to ma. The interpretation of n sin theta is equal to ma is totally different from case 1 to case 2. So this is how you work from a non-inertial frame of reference. Thank you.